Okay, that sounds good. Okay, perfect. And I will send you the a link to the recording as well as the notes that the AI takes in the transcription. So that's good. So, guys, I'm going to introduce. Oh, Dua has joined in as well. So, Dua is also. Namia was mentioning Dua to you yesterday. So, Dua is from University of Alberta. All right. Right now, she's actually in Waterloo. She's doing a co-op over there. Hi, Dua. Welcome back. Uh,
Sorry, I
yeah,
couldn't
yeah. There you go.
my mic.
That's
And
okay.
you.
Yeah, we
Nice
can
to
hear
meet
you.
you. I'm actually from Alberta too. I'm from Canmore, close to
Oh,
Banff.
really? That's so
Yes.
cool.
Crazy
That's really cool.
coincidence. Yeah.
Yeah. What do you go to University of Calgary? What university do you go
I
to?
actually go to McGill University in
Oh,
Montreal, yeah.
nice. Nice,
But I
nice.
go
That's
back
really
to
cool.
Alberta all the time because my family's there.
Oh, wow, that's amazing.
Yes.
And so Dua has been with us for a few months now. So she completed the program that we were doing with King Saud University. Dua, you'll be pleased to know that we are signing a MOU with KSU now. It's happening this coming Wednesday, so I'm going to Saudi for it, and everyone is really very
Nice.
excited. Thanks.
Yeah, that's really
And
exciting.
yeah, it's a good introduction to Nami as well. So Nami, Mr. Azam is our lead AI engineer and chief architect of the solution that we're developing. You'll be learning more about the solution in this call. This call specifically is based on describing our recent developments on how we're utilizing MRIs to now create a synthetic amyloid PET scan, which essentially saves people time and cost and money, and it helps them get rid of that expensive and invasive PET amyloid exam. But before that, Nami, I'm going to just hand it over to you. I know you have a very good presentation ready. Um, we'd like you to go through that presentation so that people joining in can get a fair idea of how neuroscience is developing in Canada and specifically in Montreal. And I see that you've mentioned McGill University and the Montreal Neurological Institute as well. Just for reference, everyone, so the MNI 152 template that we use that actually is from that institute. They're the ones who invented it, and it's a worldwide standard. So Canadians are not behind in that area. They're, I think, far ahead. They've got their A game on. So I'm just going to hand it over to you, Nami. Feel free to share your screen and start with your presentation, please. Thank you.
Okay, sounds good. Perfect. I'll just share my screen here. Okay. Can everyone see my screen here?
Yes, perfect.
Okay, perfect. Thank you very much. Thank you so much for having me today. So my name's Nami Dwyer. I'll add my email and LinkedIn in the very last slide if anyone would like to connect. But I'm from Alberta, as I was talking with Dua about, but currently I'm at McGill University in Montreal. And yeah, in this presentation, I'd like to talk a bit about neuroscience in Montreal because the neuroscience research is very big here, probably one of the biggest in Canada or even North America. And I'll talk a little bit about like McGill and Montreal and myself too. And hopefully even at the end, we have time for questions. And the presentation will be around 15 minutes. I hope does that work, Ahmed? Okay. And then we have, so for the photos here on the right, this is actually really cool. I got to observe one of my colleagues use a slide scanner, which is a machine where you essentially look at different brain slices, which was super interesting. This is for the mouse brain specifically. And then for the photo on the left, this is right by my research facility. Montreal has a lot of greenery and it's super beautiful in the summer. So I just wanted to show that. So I'm half Japanese. My name Nami is actually Japanese, and I'm actually going to Japan in July, which I'm super excited about. But I'm going into my third year of neuroscience at McGill, and I'm in the neuroscience program. And at McGill, there's kind of three streams of the neuroscience program, since neuroscience is truly so interdisciplinary. The first stream is microbiology and very biology based. The second one is the computational stream, and then the final one is the cognitive stream, and I'm personally in the cognitive stream. So Montreal is located in Quebec, And Canada is bilingual, so French and English are the two main languages. And Quebec is actually the one province where French is dominated, which is very interesting. Montreal itself is quite English dominant. I thought I would pick up some French, but actually everyone speaks English here. But as soon as you leave Montreal, most people, French is their main language. And some people can't even speak English in very rural areas of Quebec, which is a very interesting fun fact. So McGill University, as I mentioned, is a very big research hub, beautiful campus. I took this photo on the right. I'm very proud of it with the sun shining. It looks beautiful. And it's also located right by the Mont Royal mountain. It's not really a huge mountain. It's like a hill, basically. But it's very beautiful, and I love that it's right by campus, so we can go for walks. So this is a photo of kind of the McGill neighborhood area. This is the main university campus, so it's pretty small, especially compared to King Saudi University, but I really like it. It's a very close-knit, like, community feeling, and there's a big central field in the middle. And then up here at the top of the hill is actually the university residences. So this is where I lived in first year with all of the other first-year students at McGill. And then I'm going to mention this in a few slides, but the Montreal Neurological Institute, the MNI, is actually located right here, close to the residences up the hill from McGill University. So McGill has a lot of student involvement that I want to mention, and I really love this about McGill. There's a lot of science and neuroscience clubs, but also cultural clubs too. I'm part of the Japanese Students Association, where I get to meet other Japanese students and talk Japanese with them too, which is a lot of fun. And then I'm also part of the Neuroscience Undergraduates of McGill and the Science Undergraduate Society. So within Montreal, there's a lot of neuroscience institutions. I might even be honestly missing a couple here, but the MNI at the top of the hill that I showed earlier on the map is the main one. And it's the logo located on the top right there. But where I'm currently doing my research is the Douglas Mental Health University Hospital. It's about 45-minute commute from where I currently am in downtown Montreal, but there's also a lot of especially cognitive and psychology related research there, and actually a lot of Alzheimer's research too. And then there's also the Montreal General Hospital, where there's a lot of research, even some non-neuroscience related research is happening there. For example, my friend in immunology is working in a lab there for the summer. There's also a lot of universities in Montreal that do neuroscience. We have University of Montreal, UQAM, and University of Laval. So those are all the French universities. And then we have McGill and Concordia University. Concordia is located a bit far from McGill, but we always joke when we go into that neighborhood that it's enemy territory. But they have really good Asian food there, so we go there pretty often. So I'd like to talk a little bit about the neuroscience history in Montreal, because it's very rich and it started way early in the 1900s and probably even earlier too. So there's two main doctors and researchers in Montreal that are very famous and a lot of neuroscience students know about. First is Dr. Penfield. Maybe some people recognize his name, but he essentially mapped the human brain by electrically stimulating certain parts of the brain in patients that literally had their brain open. He would see what movement resulted and what patients would feel based off these electric stimulations, and basically created a representation of which parts of the body are more sensitive and which part of the cortex represents certain body areas. So if you look at the really odd looking photo on the bottom right there, the hands and the mouth area is really large because those are the most sensitive parts of the body. He also developed the Montreal procedure, which is basically a surgical technique to remove the brain tissue, which is causing severe focal epilepsy, which causes seizures. And this is all very interesting to me because the brain actually has no pain receptors. So if someone were to fully open up your brain and stick their finger in your brain, you actually wouldn't feel it because you don't have receptors. So he would be operating essentially on fully awake patients, which is so fascinating to me. There's also a story about one of Dr. Penfield's patients, Mrs. Gold, where Penfield stimulated her brain electrically and she was an epileptic patient, and she would, for some reason, smell burning toast right before having an epileptic seizure every time, and it was kind of a predictor of this event. And it truly shows how the brain is so intertwined and connected in ways that we don't even realize, and it's truly so complex. And then there's also Dr. Milner. She had a very famous patient, probably one of the most famous neuroscience cases, called patient HM. He also had epilepsy, and she removed his hippocampus, which is a part of the brain, and he did stop having epileptic seizures as a result. But one very strange side effect of removing the hippocampus was that patient HM could remember everything leading up to the surgery, but nothing after, and he couldn't form new memories. For example, he met Dr. Milner only after the surgery, and every time he met her, they had many, many sessions, he would never remember who she was, yet he could remember everything about himself leading up to the surgery. So this was a very odd case, and it led to the discovery that the hippocampus is in charge of creating new memories. And I'm actually currently doing research on the hippocampus, which I'll be talking about in a few slides. And then here we have the MNI 152 template that Ahmed mentioned is used at NCAI. Essentially, it's called the 152 template because the 152 refers to the number of the healthy young adults whose brain scans were kind of averaged together to create this template. So by combining these 152 different brains, it kind of provides a typical or average representation of human brain anatomy. This can be used in so many different ways. It's used for fMRI studies, neurosurgery, and targeting exact coordinates for procedures. And it's basically a 3D geographic coordinate system. And it's really interesting and fascinating that it was created right here in Montreal up the hill. So I'd like to talk a bit about my personal neuroscience experience now. First of all, a couple weeks ago, I had the opportunity to attend the Canadian Association for Neuroscience conference. This was really exciting and interesting for me. It was my first neuroscience conference I attended, actually. But although the science was definitely quite complicated, it was so inspiring to be in this environment with researchers from all over Canada and even globally from other countries outside of North America. There were a lot of Canadian researchers, but also guest speakers from Stanford, Yale, and other big American universities too, which was very great to see their research. It made me realize that a big part of research is really just collaboration in the same way that we're collaborating here on this talk. And that's such an exciting part of science that I love. Another thing I realized about this conference is definitely the fact that neuroscience is truly so interdisciplinary. There was a lot of computational research, biology, molecular biology, even math and physics sometimes. And that's really one reason why I love neuroscience so much, just the fact that it's interdisciplinary and there's so many different topics that come together. I'm also going to be attending the Japanese neuroscience conference in July when I go to Japan, which I'm really looking forward to. And there's definitely a lot of neuroscience celebrities that will be there that I hope to speak to. So my research is specifically looking at hippocampal brain activity, which, as I mentioned, the hippocampus is in charge of memory consolidation and forming new memories. And the lab I work at is located at the Douglas, which is 45 minutes away by commute, by train, as I already mentioned. And I go around 5 times a week, and I have a mentor that I shadow and follow him around and see the work he does. And I also have had the opportunity in the last week or so to run and take the lead on some experiments, which is great. And yeah, these photos, the one on the very right, if you look closely, you can actually see the mouse running on the treadmill, and we put them through a virtual reality task with certain rewards and cues, and then we essentially measure their brain activity. And then the photo in the middle here is actually a mouse brain, which is shockingly very small. But I guess mice are quite small, but I don't know, it was very weird holding that in my hand. I was surprised. For my for the actual procedure, we use extracellular electrophysiology. So if you look closely, you can see these like probe needle-like things going into the open mouse brain. So these are small silicone probes. They're also called microelectrode arrays. And we put them into the brain and detect electrical activity from surrounding neurons. And we use what it spits out is on the left here, the EEG output, and we use the data from these electrical signals to notice patterns in the brain, such as bursts of activity or synchronization between certain brain areas. So I get to work with mice, which is a lot of fun. They're super cute, and there's very strict rules about minimizing the number of mice we use and ethics with animal cruelty and treating them properly. I had very intense animal training too, where I had to perform surgeries, anesthesia, injections, etc. But they're pretty nice most of the time. I did get bitten for the first time a couple days ago, but it's already healed, so that's good. So just to talk a bit more about the Douglas Mental Health University Institute, it's a very historical hospital. It used to be a psychiatric hospital and there were a lot of inpatients, but now there's not as many patients, especially ones that stay overnight, and it's been dominated a lot by research, both neuroscience, but also a lot of psychology and cognitive science too, which is interesting to see. But sometimes I still do see patients around, but there's definitely way less. And there's also a very complicated underground tunnel system that I get lost in, and it's very spooky. So I wanted to kind of finish up the presentation by talking about my 3 interests within neuroscience. The first one is Alzheimer's, of course. I'm very interested, as a cognitive neuroscience student, I'm very interested in learning and memory because I truly believe that memory makes up who we are, everything we do, the way we perceive the world, the people we love, it all comes from memory. And Alzheimer's is very interesting because we lose our memories. So even looking at it from non-science, like philosophical perspective, who are we without our memories? Because our memories and experiences are exactly who we are to this day. I've volunteered with Alzheimer's patients too, and I have personal family members who had Alzheimer's, so I'm very passionate about it, and I hope to contribute to Alzheimer's research in the future, and I'm very happy to have this connection with NCAI too. I'm also interested in neuro-oncology, which is cancer in the brain. I haven't had the opportunity to explore it as much, but it's definitely one of my interests. I volunteered at the Japan National Cancer Center a couple years ago, which was a very interesting experience too, and it made me very passionate about cancer. And of course, the third area of neuroscience that's very interesting and I've recently been looking into a lot is definitely the intersection between neuroscience and computer science and coding AI. I think especially recently, the intersection between neuroscience and healthcare and tech is huge, and I really think that's the future. AI is really so advanced that instead of being scared of it, we must truly embrace it and take advantage of it and use it to learn more about neuroscience and the human brain. Even in my personal research, I've noticed that there's a lot of computer science and data analysis, and it's such a huge part of neuroscience. Even at the research conference I went to, I noticed that the topic of AI and neuroscience is becoming huge. I think the human brain is basically an example of a perfect machine almost, and we are using these neural networks, the human brain, to kind of optimize AI and even large language models too, which is really interesting to see. So this new intersection between AI and neuroscience, which is exactly what NCAI is doing, is so fascinating, and it's truly the future. AI in healthcare is really the future, as I've already said, not only in neuroscience, but also other areas of science. And I'm very excited for this amazing collaboration. And thank you very much. This is my email if anyone has any questions or would like to connect. And if anyone has any questions here, please let me know. Thank you so much.
You're most welcome, Nami. Thank you for the presentation. Very diverse. It covered a lot of areas, and this is great. Gave us everyone a lot of insight on how neuroscience, Montreal specifically, and Canada as a whole has a research background in neuroscience and these wonderful organizations that you mentioned. Very historical places I know we've got in Montreal, and McGill University is also one of them. So I think that's a fantastic program that you have enrolled in. And you're very right. AI is the future, especially in healthcare. And it's very important that it is executed and integrated into clinical workflows in a systematic manner and in a responsible manner. And that's why we've chosen this path of going to clinical trials and then FDA approval so that we complete all the compliance and regulatory requirements so that once it is launched, it can help patients and then more and more hospitals and diagnostic centers can start going for our solution. And obviously, it is work in progress. We are making headway, leaps and bounds. I think we're doing very well, especially over the last 6 months. I think we've made a lot of headway. And as you'll see in this presentation from today, and I see Maria, I think, had her hand up. Maria, would you like to ask a question?
Yes, please.
Please
Hi,
go ahead.
Nami.
Hello.
First of all, Nami is a lovely name. Thank you for
Oh,
coming
thank you so much.
today and joining us. So, I'm very interested because you're working on the cognitive part of neuroscience. So, basically, um, I have a genetic engineering bachelor degree from South Korea, Songyunkwan University. And during my time there, I actually worked on neuroscience as well, but mostly on the neurodevelopment and stem cell. So most of the time we were working on basic research, like just the effect of certain protein mutations, and like we would see this activity on um, on imaging, but most of the time it was on brain samples that were already like from dead rats after we did those mutations, protein mutations. So it's very interesting that I like in the cognitive side of the research, you get to actually work with a working, living brain. So this is very interesting to me. And I just, my question is, how is it different? Have you ever like tried the basic research on neuroscience, and how is it different from cognitive on, or like on real living mice in vivo? Both of them in vivo, but like on living mice.
Oh, yes, that's a very good question. Thank you so much. And that's really interesting that you did the genetic engineering program. That sounds very fascinating. And I also love Korea. Um, but I think this is actually my first research experience and work that I've done at McGill, which is working with the mice and more on the cognitive, almost psychology side of things. But I'm definitely very interested in the proteins and more looking into the biological part of neuroscience. I think I personally really love working with live mice and seeing kind of their behavioral changes and effects. But at the end of the day, I think no matter what we see of, oh, the mouse loves this reward and the mouse remembers this reward, I think we need to get to the root of neuroscience and to do research that'll really contribute to healthcare. I think you need to dig deeper and look down at the proteins and the biological mechanisms too. So, and I think with my cognitive research that I'm doing, we're looking at specifically the brain activity. So not only the behavior, but kind of one layer below, which is the brain activity and the EEG, like I mentioned in my presentation. So I think that's such an important part, kind of digging deeper. And I'm very, very interested in biology. And I'm hoping down the road to definitely work at a lab that relates more to that side of things too. Does that answer the question?
Yes, thank you very much. And I hope you get the chance to try that as well. It's actually very fascinating. And I hope I get the chance to work with like on the cognitive part of neurodevelopment and neuroscience, and also as well during this program. I'm trying to learn as much as possible on how to integrate the AI and the new technology into all of this.
Yes, exactly. I think the intersection in neuroscience of the computer science, biological mechanisms, and then, of course, the mind and the cognitive aspect is really the best golden spot for sure.
Perfect. Thank you. I see Haifa has joined as well. Haifa, you're a bit late today, so I think you missed Nami's presentation, but it's okay. You can review the YouTube recording. So we'll have that up over the weekend as well. Now, I'm going to hand it over to Azam. Now, before I hand it over to Azam, I'm just going to fill everyone in, everyone who's on the call, and obviously everyone who's going to view the recording. So, machine learning and deep learning, and this is so I don't come from an AI background. So I'm a PMP, I'm a project management professional. So coming from me, this is going to be something that simplifies things for you and sort of gives you a high level understanding on how we approach things. I use this to explain it to doctors as well, doctors who have no clue about AI, and they find it to be very useful. So it's a useful example or, excuse me, analogy that I'm going to use. So think of it this way: machine learning and deep learning. So we have a person who's sitting on a chair. Let's say we put a real sense camera and aim it at the person, and we set the timer at, let's say, a couple of images, 2 images every second. So that's 120 images in a minute that it's going to take, and then you can do the math, and let's say we have it placed over there for like a month. So for a month, it's going to build up its data set that it is going to train the AI model on. It's going to capture hundreds, thousands of images of that person. That person in different days, different makeup, different hairdo, different clothes, sitting, standing, writing, talking on the phone, shouting, screaming, different emotions. So it's going to capture that person from every angle over the course of the month. Okay. Now, what we do is we train the AI model. And once we have the AI model ready, we say we test it. Okay. We pick a room full of 50 people and we put that person in that room and we ask the AI model to pick out that person and it picks it out, it's accurate. Then what we try to do is we try to trick the system. So we look for false positives and then we look for false negatives. So we find another person, put that person in the same room, and give that person the clothes of the first person that the model has been trained on. Now, that model looks at this new person and says, oh, okay, this is the same person, which is wrong. That's a false positive. So it has falsely, positively identified that other person as this person, which was not the case. And then we look for a false negative in the same vein. So we give the second person's clothes to the first person, and then we have the model take a look at it, and then we pick out the false negative. So the person says, "Oh, no, it's the model says it's no, not that person, whereas actually was that person." Okay, so that's another false negative that you have over there. Then we think, okay, you know what? We need to train this model to a higher degree of level of accuracy. So we say, okay, you know what? Don't judge the person by the clothes or the makeup or the hair or the expressions. Let's go for other stuff that will be difficult to replicate by other people, and hence the model will not be easily tricked. Then the deep learning facet of it kicks in and it starts looking for stuff like moles or scars or birthmarks and stuff like that, which one person is has it, but another person is less likely to have the exact same thing. Now, then we go a step ahead. We say, okay, you know what? Let's leave these games with identifying the person and then looking for the clothes and the makeup and then the scars and the moles and the birthmarks and whatever. Let's create that person. So you have enough data, you've analyzed this person head to toe for a month, you know what their stance is, you know what their height is, you know what their gait is, how they walk and everything. So make me a synthetic model of that person. And then the machine learning and obviously the AI model kicks in and it starts giving you a synthetic image of the same person. Think of it as a hologram. Okay. So this now translates into neuroscience. What are we doing over here? So guys, what did we first do? What was our first model? Our first model was we took MRIs and we took fMRIs and we from patients who had different stages of Alzheimer's, whether it was MCI, mild cognitive impairment, or early onset or aggressive or whatever. And then we trained the model on it. And then we taught the model, okay, you know what? These MRIs or fMRIs belong to these categories. And this is how now you're going to pick. Once we train the model and we put a new, upload a new MRI, then you're going to compare it to what you've learned, and then you're going to give us a result. So we did that in the first phase. In the second phase, what we did was we trained the model on pairs of data. So for the same patient, we took the MRI and then we took the amyloid PET and the tau PET scans for the same patient. And then we trained the AI model on that. Now, what was the correlation, if you guys remember? So with MRI, it correlates to PET amyloid. Alzheimer's causes hippocampal volume reduction, atrophy, and then that is visible to some degree in the MRI. And what does the PET amyloid do? The amyloid buildup causes the same problem, brain atrophy, shrinkage. There's the connection over there. So we train the model on both the MRI and the PET amyloid. And once it had enough number of subjects and images in there, it then started to predict with the input of a simple MRI what the corresponding amyloid PET scan would look like. So it started giving out its own prediction and simulation on that. So that is what we're doing now. We give it a simple MRI and we ask it to make a simulation of what a corresponding PET amyloid scan would look like. And the results are pretty accurate. It gives you the concentration of the amyloid. It gives you the quantification. It gives you the distribution, which areas it's more densely populated in, and then our other model, which is based on RAG, retrieval augmentation generation, that kicks in. Think of it this way: that the first two models are in-house. We've got the data from various sources. We've got nearly 1 million images of data right now and counting. We've trained it in-house, so that gives you the first result. Then we use that result and cross-validate it, because there's a universe of data out there. There's so many LLMs, so many research publications, so much stuff out there. But we train our LLM to interact with the right LLMs in the right manner. So it's not like a simple case of just using chat GPT at the back end and just uploading something and just getting a, a report of some sort. No. So we use retrieval augmentation generation so that it picks out the best research, the best people, the best papers, the best models out there, and it cross validates our solution, our diagnostic report. And then in the third phase, it feeds it into the explanation AI model, and then that gives you a result which quantifies the readings and also gives you written assessment and explanation of what those readings mean, as you can see in our report. So it's pretty comprehensive. We've left little room for error. The first couple of models I mentioned, accuracy rates are 97% plus. This new model that Azam has developed, the synthetic PET model, accuracy rates are currently 85% and going higher, inshallah. So I'm going to hand it over to Azam, and he will walk you through our presentation. This is the same presentation that I will be giving to King Faisal Hospital people this coming week, and I'll keep you guys updated on how everything goes over there. So, okay, so before I give it to Azam, a couple of things. So this week we're signing a MOU with King Saud University, number one. Number two, I'll be visiting Almaarefa University because we have a pending MOU with them as well, and they're interested in us setting up an AI lab over there, similar to the one that we have set up at King Saud University. Then a couple of other things. I'll be going to King Faisal Specialist Hospital and Research Center because, as you guys know, we have a clinical trial pilot and which is under process right now. So there's a ton of paperwork that we're doing for it. So I have a meeting scheduled for that purpose over there. And then there's another institution, KAIMRC, King Abdulaziz Medical Research Center, the biggest research center in Saudi Arabia. So they've invited us for a research collaboration as well. It's pretty similar to what we're doing at King Faisal Hospital, minus the clinical trial, although they're looking into it. They'll be giving us data, we'll be training the model. So they're going to be helping us in research publications as well. And by the way, Nami, I'm going to get you involved in the research publication as well. So I think that's something that you can really contribute to. We've got the other girls over here, Maria and Haifa, and I'm forgetting a couple of names. Those girls are working on research as well. So there's a research task we gave out to them. We'll forward it to you too. So you can work on it on your spare time. And yeah, so exciting times ahead. And Mr. Azam, over to you, sir. Thank you.
Hi all people. Basically, today presentation is based upon our new model. Basically, model is based on MRI based PET amyloid synthesis and quantifications for early Alzheimer. As Mr. Ahmed also talk about a lot of things which we basically done regarding the AI perspective for different models like classification model and further the PET amyloid synthesis. And recently, the gold standard is that how we predict the PET synthetic amyloid images from MRI. Basically, the idea is that we put the input, as you see that in the slide, the idea we prepare a model and give the input of simple MRI, The MRI is not pre-processed in raw format like DICOM and FT format. And first of all, we pre-process the MRI from NCA-based pre-processing pipeline uh, regarding different tasks. And we also utilize some top-of-the-line pipelines like fMRI prep and Clinica, and top-of-the-line libraries like FSL and NI Bible. These libraries are also utilized for our customized pre-processing pipeline. And we put the MRIs in our pipeline, and when we give the input of MRI, the MRI uh, we process the data for different pipeline method like normalizations, uh, like the data augmentations, and the main thing is the code expressions. But in this case, our engine have already paired the data MRI and PET amyloid images from different sources like acne, OSIS, A4, and we also uh, get some other reliable sources like small research institutions. Today, I share you the where the hundreds of the thousands of images are available for different um, scanning images like CT scan, MRI, and ultrasound and other reliable sources. Now I came back to our presentation.
Mr. Azam, before you go ahead, I'm just going to add something. So, guys, Nami, Dua, everyone else, although I think Dua is already aware. Nami, so we have these machines and servers set up at King South University. We can give you remote access to them if you would like to utilize them. Now, these are the ones with the NVIDIA super chips, and they're pretty fast, and they've got a lot of storage and a lot of speed, processing speed. And we've got all those data sets over there as well. So if you ever want to do any research or you need any neuroimaging software, so MATLAB, FSL, we've got Clinica, everything is over there. There's a long list of software. So if you ever want to do private research on your own and need access over there, we'll just send you the login details. You need Rust Desk remote access software for that. So you can just download it on your laptop and you'll be able to access all the data sets and everything. So that's something to note for future use.
Okay, thank you very much.
Welcome. Back to you, Mr. Azam.
Now the main thing is that NCAI, basically we develop a hybrid model which based on convolutional neural network fusion, and also we are utilizing the shear GAN generative adversarial.
Azam, I think we just lost you over there. Could be a network issue. Sometimes we lose power supply over here. It takes about 3 to 4 minutes for the power generators to kick in. So I think that might be happening. Can everyone else hear me?
Yes, we can hear you, but Mr. Azam is not available. His keen.
Yeah. Okay. So just give him a couple of minutes to come in. Before he comes in, meanwhile, I'll fill you guys in. So this slide that he was currently on right now, I actually made that slide last night. It was for the benefit of the doctors because we sent them the data sheets and information about the data sets and everything previously, but I was not able to get a hold of them on the phone, and then asked me to come in for a presentation so I could fill them in on how this system actually works. So it's very simple. So we've got the portal. There's a portal where you go. A doctor will sign in. After signing in, the doctor is going to bring up their patient's profile. It's going to have all the historical data for the patient. So, for example, excuse me, if the patient came in for MRI this year or last week, going to have that information and even MRIs from previous years. So what the model does is not only does it give you an assessment of the MRI that you're uploading right now in real time, but it's also going to give you a comparative study of the MRIs that were previously uploaded for the same patient in the system. So it can give you, and you can converse with the model. So it's got a neuro co-pilot over there as well. So you can, both English and Arabic, by the way. So you can go and ask the model questions like, for Mr. Smith, can you give me a comparative study or a graph which depicts his hippocampal volume reduction over the past 3 years? And it can give you a chart or a graph which shows how the hippocampal volume reduced over the 3 years, previous 3 years. And that's how the model can then tell you, even if the person is not experiencing any cognitive problems at the moment currently, but it can give you a prediction that, you know what, the hippocampal volume is shrinking at above normal rate. And this could potentially mean that the person develops Alzheimer's in the next 3 years or 4 years or 5 years or 2 years or whatever the diagnosis is. So that's number one. So what happens is you have a question and answer session with the patient. You input all the information like customer name, gender, family history of mental disease, lifestyle, eating habits, diet, everything. And then you take their MRI or fMRI and you upload it to the system. And then the system is going to run it. It's going to give you a diagnostic report. The diagnostic report is going to be split into 2 or 3 parts. So on the spot in real time, in maybe 2 minutes, it's going to give you an initial 2-page report, which is going to give you the diagnosis at a higher level. Okay, this is what's going on, suspected Alzheimer's, this is the classification, this stage, and these are the next steps. So, number one, and what are the management? How can the doctor and the patient work together to manage it? And then, obviously, there's a more detailed report, which will probably take a few hours to generate with the current speed we have right now. And then that report is basically the 25 or 30-page report. It's going to have 2 parts as well. So the first part is the hippocampal part, atrophy part, and then the DMN network part, and then this new part, which is the synthetic PET amyloid part. So we are going to trim that report down. We're going to bring it down because I think it's very, very long right now. The doctors do agree as well. But right now, what we're doing is we're giving the doctors this extended report so that they can have a look at it and they can tell us what's extra in it that we need to remove, and whatever's missing we can add. And we're trying to tailor make and customize it to their requirements so that we give them something that they embrace at the end of the day, because they're the ones who are going to be using it at King Faisal Hospital, which is going to be, inshallah, first hospital that we deploy at, and then other hospitals and in other countries as well. So once that report is there, it's in the hands of the doctor. Then the doctor looks at the report. The report is not to be considered as a replacement for doctors. It is something that is going to assist the doctors, the neuro co-pilot as well. But I think they're going to find it very, very useful. So far, we've got some great reviews from over there. If you can hold on just a second, let me see if I can pull up the presentation. Just I'm on my phone right now. Just give me a sec. Guys, can you see my screen?
Yes.
Yes, sir, we are. Yes.
Okay, perfect, perfect. Just a sec. Okay, there you go. So this was the slide that Mr. Azam was on. So initially he was telling you about what the NCAA model does. The input is a single MRI, and then what a synthetic PET amyloid scan is. So as I said, it's basically a simulation. You give it an MRI, and you ask the model to create a simulated amyloid PET scan for you, and it does that. It gives you everything you need to know about the amyloid status for that patient. And just to remind you guys what amyloid is, so the body, the brain builds up protein in the brain called amyloid and tau. So normal process is the amyloid and tau build up, and then the body breaks it down, they build up again, breaks it down again. That's the normal process. Now, the abnormal process, which leads to Alzheimer's, is that the body builds up amyloid and then does not break it down. It starts forming clusters in the brain and it starts eating away at the brain, in layman's terms. And then that is what causes Alzheimer's, because it causes hippocampal volume reduction and other problems. What does the amyloid PET scan do? What does it entail? You inject the patient with the radioactive tracer, goes all the way up to the brain, and then you do PET imaging. And if there is amyloid over there, the tracer is going to get attached to it and it's going to highlight it in the PET scan as a colored area. It's going to show you how much amyloid is there, the quantification, concentration, and the distribution, which areas of distribution, which core areas is it located in. This is also very critical because there are some areas where very, very crucial. And then there's the outer level areas which are not as crucial. So that's also very important. And then as I said, the NCI model is then going to give you a diagnostic report. I'll go through the report as well. So the next slide is basically more of the same. I created the first one for the ease of understanding for the doctors. So we have our structured MRI, which we give, and then the NCI data pre-processing pipeline, which you guys know does all the pre-processing on its own. Pre-processing steps, we've given presentation on that. I think we gave it to the KSU people. We'll devise one. I gave that presentation, so I'll do one for you guys as well. So that has all the pre-processing steps like segmentation and skull stripping and MNI 152 registration and so on and so forth. So this is what the model does in the first phase. Then in the second phase, obviously it runs it against the deep learning model, which uses pattern recognition and LLMs, and obviously the PET synthesis engine. So this is an example of the predicted synthetic PET it created. Now it created this from the input of a simple MRI. And this is groundbreaking right now. This is the hot item in the market right now. People are really working on it. There's a lot of research being done on it, but a lot of research being done isn't being practically applied or executed or implemented like we are doing it right now. So this is how NCAI is standing out. So I've shared the presentation in the group as well. You can take a look at the data sets that we've used. So I asked Mr. Azam, I said, you know what, just before you guys logged in, I said number of subjects we've used are a bit low, 728, 678, 631. But obviously he said that for each person, think of it, there's 3 views, and for each view, you can have up to 100 slices. So for each person, if we have 300 slices, then for 700 people, you can do the math, right? So it's not a small data set. And we have access to a lot of data sets. We've got data set which has more than 50,000 patients. So we're getting to it. This is just a start. In the next couple of months or so, you'll see the number of these subjects go up higher and higher. What you also have to consider is that why we are getting Saudi patient data from hospitals in Saudi Arabia is because all the doctors have urged us that people in Saudi Arabia or people in this part of the world in the Middle East are going to have different MRI characteristics, for lack of a better word, as compared to people from North America that are included in most of these data sets. So they said that you have to retrain the model on local Saudi patient data. So that's why we are doing it, and then we're heading to clinical trials, of course. Now, what phases are involved? So there's the inference phase. So you take the MRI and you input it, and then there's the PET generator, and then the next phase. It goes through a couple of steps, which Mr. Azam will describe in more detail than myself. And then the end result is a synthetic PET. Now, we've also given two diagrams which give you a comparison between the real PET scan and the predicted simulated PET scan. Because remember, the patient data that we trained the model on, we had the pairs of data. So for the same patient, we have the data, the MRI data, and then for the same patient, we have the amyloid PET scan. So in this case, we took the MRI data and we made a simulated synthetic PET, which you see on your right. And then we compared it to the real PET scan that we already have. And you see how it is so similar, 85 to 90% similarity over there, which is very high. It gives the doctor what it's need. It gives the complete quantification report and the result. So the MRI-based PET amyloid synthesis, again, more of the same. So we've used internal data sets and external data sets. And it's just showing you more of the same. That So SUVR, I'm going to discuss in the report when I pull it up after this. So keep that in mind, the standardized uptake value ratio. That is very, very important in diagnosing Alzheimer's. Now, the MRI-based PET amyloid synthesis, so there's a couple of graphs over there as well, which gives you comparison between the real PET and the synthetic PET. And this last second, third, and third last slide, so this one that you see over here, we're going to talk more about this in the report right now. This is again the synthetic amyloid PET scan, which is then quantified, and I'll just show you how it is being quantified. So this table, the SUVR table we call it, is very, very important. It gives you SUVR value, it gives you a Z-score, alpha beta lower, alpha beta index, and obviously the CL score as well. So which is called the centralized scale. So read about this, do some research on it. You have the presentation and the report and you have the diagnostic report as well. Hold on just a second. Are you guys still with me? Hopefully.
Yes.
Yes.
Okay. Okay.
Yes,
Okay.
yes,
Perfect.
sir.
Perfect. Perfect. Okay. So there you go. So this is just a section of the report. So there's a full 30-page report, which I will reshare in the group, although it's there in both groups. But this is the recent addition to it. So as you can see, this is what we've done. We've given it a MRI, and we've asked it to create a PET amyloid synthetic one based on a simulation. And this is what it has created. It has given you reference regions, it's given you target regions as well, and it's given you a quantitative amyloid burden assessment, which has the SUVR, the cerebellum score. Now, this is showing a high uptake. High uptake means that it's usually Alzheimer's. So there's a scale for it that you'll see down here as well. In the larger report, there's more information on that as well. And it's going to give you information, there you go, about regional distribution and the clinical correlation, the MMSE score. So that is also very important. It shows you MMSE of 16 out of 30 is usually going to mean cognitive impairment has started. So Alzheimer's is being diagnosed for this patient. We use explanation AI, which then takes these figures that have been quantified and then gives you an explanation of these figures. We're going to wait for Azam because I think he's going to be the best guy to give you an explanation for what each of these items are, which would be the last thing we do before we wrap things up today. But you guys can take a look at it on your own as well. Dalia, thanks for joining in. I'm just worried about Azam. I don't know if you lost electricity or maybe you lost internet, but hopefully I'll have a chat with him after the call. I see our time is nearly up as well. Now, do you guys have questions? I'd like to ask each of you, Haifa, Maria, Nora, Dalia, especially who just joined in, obviously Dua and Nami and Hasib as well. I'd like you to guys to have like a brief conversation, like any questions you have. What do you think about this report? You can give me your feedback. It doesn't have to be a question. You can just give me your feedback as well. Let's start with Haifa. Haifa, I haven't heard your voice in a while. Nora. Okay, let's start with Nora. Nora has her hand up. Go ahead, Nora.
Hello, how is everyone doing? I have a question on the report that you said the doctors were giving you feedback on.
Yeah.
That it was too long, or I don't know if I misunderstood the concern of the doctors. I was just wondering if we could if some of the doctors could join in on later sessions or give their input on the diagnostic report, I think that would be helpful from the perspective of a medical student.
Yes, you're right. So number one, yes, they found the report to be long. Well, we already knew it was long. Report shouldn't be more than 6 to 8 pages. Even that's a bit long. Should be, ideally should be like 4 pages, 5 pages, less than that. But we wanted to show off our system that it's giving you all this information. Number one. Number two, we were not sure. Still not sure actually what exactly the doctors want in terms of imaging and graphics and charts and bar charts. And so that's why we gave them everything. We gave them the full menu, the full 7-star meal. And we said, okay, now you try it. And then you tell us what you want taken out and what you want retained. So we're still in process of doing all that. So with both King Faisal Hospital and KAIMRC, in the future, yes, I can get you guys to have a session with the doctor. We can have them come in and they can go through the report. They can also tell you what the report means, what it entails, what specific parts of it mean, and what their feedback on it is. We'll try to get someone from KAIMRC because the King Faisal people are very difficult to catch. It's very, very, very difficult to get them on phone calls because they've got patients and everything. They don't usually have time for students, but we'll find someone from KAIMRC who can come and walk you through the report from a neurologist perspective. So yeah, we have that on the agenda, but probably in a month or two this summer, inshallah. And over to Haifa now. Haifa, how are you doing?
Hello, Mr. Ahmed. Alhamdulillah, good. How's everyone doing?
Good, good, good. Haifa was kind enough to send over a package. So her mother works for the Royal Consulate in Saudi Arabia, and she sent over a wonderful package for us for NCAI. And it's very, very nice of her. And she sent a very nice note for fighting Alzheimer's in Saudi Arabia. So that was very, very nice, very cool. And Haifa, I'm coming next week, so I'll be visiting Almaarefa University as well. I told you they're interested in us setting up an AI super lab over there. So I'll let you know about the schedule. Probably going to come on Thursday because I have a very short schedule. Wednesday and Thursday, I'm in Riyadh. Then Friday and Saturday, I'm going to Makkah. On the way, I have a meeting in Jeddah as well. And then after Makkah, I'm flying to Dubai for a meeting over there. So it's a hectic next week, but it's going to be good, inshallah. So I'll keep you updated. And why don't you guys tell me a little bit about the research task? I know Maria's been working on it, and Haifa sent me her version of it. So what do you guys think so far? Haifa or Maria?
Yes. So I've reviewed over like 16 papers, I'm not sure. And I made sure that the selected ones are based on the relevance to the scientific quality and the contribution to the current knowledge. And I also made sure that the recent peer-reviewed studies are prioritized into the literature review to ensure that it's based on reliable and up-to-date evidence. But instead of making an Excel spreadsheet, I just made an evidence table, and I really hope that this is fine and acceptable.
Yeah, that's fine. That's not a problem at all. Dr. Azam actually reviewed it. He said this is very good. So he had more comments that he was going to share today. I've just messaged him. I hope everything is okay. It doesn't usually go offline like that, so I hope it's not an emergency or anything. But yeah, he will be in touch regarding the research task. I know you got, who else was working on it? Maria, were you working on it as well?
Hi. Yeah, I'm currently focusing on 2 papers, the ones I shared in the WhatsApp group.
Okay.
So I took a look at Haifa's report and tried to find different papers just to make sure there's no repetition. So basically, the 2 papers are related to MRI-based assessment of tau pathology. One of them is just like traditionally investigating how structural MRI features used to predict tau accumulation. The other one has a more like a futuristic approach, I would say. So I'm trying right now, my focus is trying to um, understand. So I'm still going through the methodology and results because
That's
I
good.
want to get,
It's
yeah,
very
I want
good
to
that
get a
you're,
solid understanding of the
yeah.
model.
Yeah, it's very good that you're focusing on tau because initially all of us are focusing on amyloid. So I think it's a refreshing change that you are targeting tau because tau, remember, there's always less data out there for tau. Amyloid is more popular, as per se. But I think it's good that you're targeting tau for research. I think it's very good. I think you're on the right track. The paper you've chosen is good. And
Thank you.
yeah, you got to understand it and then you got to explain it to us because remember, for us, it's a learning curve as well. I see Mr. Azam has joined in. Mr. Azam, everything okay?
Side.
Ah, there you go, Mr. Azam.
Yeah, yeah, I think so. My connection is disconnected.
Oh, the internet. Yeah, could be,
Yeah.
could be. I thought you lost power or something.
No, no, no. It's not a lost power. I think that there is fluctuation in the because this
Yeah, we had a lot
road.
of that yesterday. So yesterday, what happened was, so our home electricity meter, which usually is at 240 volts, right? So
I
it
uh,
shot up
where,
to 350 yesterday.
where I missed the slides. I show you my slide is in your side.
Hold on, hold on. So I went through the slides. So I've completed the presentation. I went through the slides and the diagnostic report as well. There's just a couple of things that if you can explain to us. So one was
Okay.
the so if you scroll down, yeah, I went through all of this. Just scroll down to the table. Yeah,
Yeah.
this table. So if you can speak a little bit about this table, about the SUVR, about the Z score,
Yeah, yeah.
CL.
Basically, the SUVR is a value which we are calculating from the previous diagram. You see that we calculated the SUVR value for the reference region to target region. And basically, if you move for the last slide, you see that the SUVR is a region of interest, ROIs. Basically, these previous diagrams show that the if you see that basically these areas are the ROIs. We take the seven ROIs, and after we take the seven ROIs, we calculated the average value of for the calculation of the SUVR and the some mathematical formula of the SUVR, the readings of the all the values, and sum that and divided by 7. And after that, the value we get that basically if the value is more than 1, it means that you are high and uptake of the amyloid and you are in positive condition. If your value is below 1, it means that you have not a high uptake, but some uptake is that. Similarly, the other thing is positive thing is center CL value. Basically, the CL value is the centralized scaling. Centralized is also the global SUR calculation is also calculated on the basis of reference region, and if you have the values scale is also available in that. If we have the centralized value is more than 30, it's mean we have in the positive condition. Similarly, the last thing is Z score. Z score basically is calculated on the basis of the SUVR and CL value. The formula is also available. You you can get different search papers and different uh, things. The formula is available. How you calculate that, and also I am sharing you the formulas, all the values. And after that, the fourth thing is the alpha amyloid beta load. Basically, it's also a formula of SVR, CL, and Z score basis. We calculate the ratio of 55%. Basically, it's too much high ratio. And the last thing is also the indexing of the amyloid beta index. Basically, these all readings are belong to the persons who are dealing the PET amyloid, scaling and regarding the Alzheimer reports. Similarly, the reports which are uh, from the normal anatomy of the person, like the different tests of like your blood sugar test and like your liver lipid profile test, the different things and different ranges. Basically, I cover in the last slide the all the ranges value, how the things are. Basically, this value is too much critical value, and all the things based on the centralized thing. Uh, I think
Okay, perfect. So I have a couple of questions, Mr. Azam. So number one, um, the students that have been doing the research task that we gave them,
yes,
and one of them, Maria, she's focusing on a paper. Well, she's one step ahead of us. We have our focus on amyloid PET right now, but she's focusing on a paper which is essentially doing something similar for tau PET. So I've asked her to further research it. She's going to go through it in
no, no,
detail
no,
and
no,
she's
no,
going to.
no.
No?
The idea is totally same,
Okay.
because in the our research we are using one flavor of biotracer, basically the biotracer of PET amyloid. Basically, the very basic biotracer is chlorophyll,
Yeah.
and other fluorometamol and other 4 or 5 biotracers are available in the case of PET amyloid. The idea is that you get the pair images, and the pairing is also available in the site. Basically, the site is gain. If I am searching on the internet, basically this is the site which also available the lot of data of all the gain. Um, now, its real name is not at the fact that the real name is Gantt. Again, is a site, basically is the abbreviation. I share that in the where all the information, lot of information is available regarding the power tau PET and also the PET amyloid. The idea and the framework is same, that uh, at this point we are making a pair of MRI and PET amyloid. You also make a pair of MRI and tau. And if you are uh, there is basically the phrase that if you are not interested for synthesization, you take the real images of the tau and apply the quantifications. Before the quantification, you must have the idea of the segmentation. And today I am also sharing you some good resources. Uh, Basically, this is a model and very good model. The model is segmentation thing model, SAM model, and the person, some person also make utilize such model for medical imaging segmentation, and is named that the SAM for MIS. It's mean that the main model is segmentation anything model, and he is using such model from medical imaging segmentation. This is good paper. You understand that how the things medical images are segmented, that if you see the diagram, basically in the second diagram, you see that you give the 3D medical images, and the 3D medical images regarding your brain, regarding your lungs, and other thing. And the other thing is that the model spotted both things. It's also spotted from video images, video frames. To see that, you give the video link also for training of the model. And after that, when you give the input, the model also encode that, and after that the mask the encoder and prompt the encoder in the form of 3 ways. You point out, you make a box, you made a mask, and you made a dots for your segmentation area. And this is very good model. I also send the link of such model And other site is that which is also very good site. The site is the um, a paper, basically the project imaging X. This is a repo where you got 1,000 more open medical imaging data set regarding the whole body. And this is very good, interesting. Some people are doing some other like the chest x-rays. If I am basically, this is a diagram. Basically, if you are we are dealing the head and neck area, basically the MRIs of the brain. You see that the segmentations of MRIs, and this is basically brain image. And also you detect the chest, you see that the boxes of the pores for the area which is infected by the chest disease. And the other things, you also doing the your abdomens, and you also do the pathology, and also this dealing your skin like diseases. And these all data sets are available in projects X. And you see that there is lot of images are available, the links are available. I am also sharing the link. You go to your category, and there are a lot of things. If you are going to the MRI data set, you see that there are a lot of data sets, and the links are also available, and the paper links are also available. You study that. Are you listening me?
Yes, Azam, we can hear you.
Okay. Any questions?
Maria has a question. Maria, please go ahead. She had her hand up.
Um, Mr. Azam, if it's not any trouble, would you please take a look at the two papers I sent on the WhatsApp group, if it's appropriate for the task? Because I actually searched and found these two papers, and intentionally chose to search about tau for change. So if they are appropriate, you can tell me to proceed, because I'm already trying to study these two papers and just do a certain type of comparison in the report paper. If not, then I can change them with
Uh,
something else.
the first question is that what is your purpose of your research? Basically, there are I am doing different models and also working some other things, some good things which save my time. And the first thing is that if you are dealing the model, there are three areas of the model. First area is that you have a thing, classified thing is available. You interpretate the thing like explanation AI, like some plots, some graphs. Basically, this is the thing. Also, a lot of people are working on that. And one thing is that you uh, get data sets, and after getting the data sets, you make some model. And it depends upon which type of model. If you are basically segmented the things, then you are choosing the convolution neural network. You also choose the transformer models like the encoder and decoders. I read your paper. I wait a minute. I share you that your paper is also. I am studying that your paper. You are NCAI Marifa group. You are sending that. I am. Wait a minute. I share my screen. Basically, this is your paper. Uh, Wait. I share that. Are you see my screen?
Yes.
Yeah, basically this is a paper Maria sent, two papers sent. This is the very first paper, and the paper is predicting tau accumulation or cerebral cortex with multivariant MRI morphy measurement, sparse coding, and concurrency. Basically, this is uh, not a you see that. First of all, when you select the paper, uh, first of all, you see that their publication thing. I think that the manuscript is available in 2021. It's a 2021 paper because December 26 is not coming. I think so. The publishing date is uh, December 2021, and you see that there are covering too much thing. First thing is that the accumulation area for the calculation of the tau accumulation for cerebral cortex. Basically, the cerebellum area is the target area, and multivariant MRI morphy. It's mean that you take two things. To take the pair of two things. First pair is the tau images, and the second pair is your MRI. And in MRI you calculate the different thing, and you if you goes to the abstract. Basically the abstract is the thing which are available, that how you get the things. Basically the abstract says that the biometric maker assisted diagnostic and intervention in Alzheimer's disease may be the key of. Basically these are the notations. The basic thing is in previous. Basically, this paper is the sequel of the previous paper. First of all, you study that how the person is work in previous paper. Basically, the previous paper is based on the hippocampus multivariant morphy study. And I suggest that first of all, you get the paper which have the data sets easily available. That you see that he is predicting more complicated things. It's not a journal paper. The data sets is also available for MRI is get from 9 to 25 subjects from ADNI, and also he get the pairing where he get the pair images of. You see that each subject has one pair consisting of PET image and MRI image. It's mean that when you collect the data from ADNI, the person should have, when the person which you get the MRI, it should have one MRI of the PET image. Basically, the idea is that if you have not a pairing of that, how you integrate the thing in the co-registration? Um, this is the idea. I don't know which thing you are. Your target goal is. I am not clear with your target goal. How you choose such paper for which perspective?
Azam, I'm going to add something over here. I think the aim of the students right now, when they choose the paper and do the research, is get an understanding of what the paper is, and then they compare it to the work that we are doing. So I think they've tried to find a paper which is similar to the work that we are doing, that we are creating now synthetic PET scan, amyloid PET scans from MRI.
No, no.
So
Basically, if the people are working, overwork is based upon three different things. They are first targeting. We are targeting three things in one idea. The first thing is that we are uh, generating the PET from MRI. These papers are too much different. These papers are basically the tag of the MRI base, PET amyloid, MRI base, PET tau. Basically, these are the target papers. Which people are targeting that. How the terminologies are using for synthetic generation. Basically, the two things which are generating these synthetic things. First thing is GAN, generative adversarial network, and the other is that encode transformers. They are transformer diffusion models. Diffusion means you diffuse the image and we create some other image. Basically, this is the idea target paper. If the people are targeting the synthesis process, and the other is that for quantification point of view, if the persons are just quantify the thing, they do not need the pairing of the paper. They just collect the PET amyloid images yeah, just collect the tau images, and after that they apply the segmentation models. Basically, segmentation models are, you also apply the SAM. SAM is also a model freely available. You apply your own convolution neural network. It's depend upon your skills and your previous like your working. It's not easy things. You just go
Yes,
one go.
yes. See, my point is, I don't think most of the students have a programming background or they're not building models themselves. I think this is the exercise of going through the papers for them is understanding the process and understanding what's going on.
The good
It-
idea
but-
is that people, I also share in my first lecture the best sides of these Hugging Faces. People go to the site. There are a lot of models, built-in models are available in that. They just get some model similar that if I am getting some OCR model, you see that we have different OCR model. First of all, just example, the person he is developing the OCR model, we are just going that, and after that we take their model, and there is option that how you utilize that model as a transformer, as a collab. You just say, and after that you also download such model. The file is also available in the model. You, after you go there, you see that there is a file. Basically, the model dot sense then safe tensor is a file which is using for model is a very large model, 10.6 GB, and two other files like the processor configuration and processor configuration is also available. And I also upload the code in the tutorial in our GitHub lab. You just follow such code and download as a CLI for any model. Yeah, simply you can download that. You simply go to this thing, and after that, you just click the download and the model is downloaded. But sometimes it is difficult for people. Sometimes you just give such thing in our code, and our code download the Hugging Face model in your machine. This is good idea.
Okay, so this is for those people that who want to learn model development. I think this is something we've discussed before as well. Go to the Hugging Face website
Yeah,
and
yeah.
then just play around over there. But Mr. Azam, what I wanted to do was I wanted to get two or three girls from the research group, and I wanted to pair them together and then attach them to you so they could help you with the research publication that you are making as well. So my aim was that these girls don't do model development or AI model development or on their own. My aim was that they go and do research papers for you so that they can bring summarized information to you, and then that
Yeah, yeah.
information can help you
Basically,
with.
it's good idea. They are getting some related research tasks which we are doing. Same like that, I am doing that. The MRI based PET amyloid synthesis. They go to the websites and choose some good paper, and the target area is that we also provide the target area. These targets we get the papers, and we conclude on such papers. In every paper, um, we conclude to some such students. They conclude their own words, not using just go to the GPT and put on that and get some acceptance.
Yeah, that's very important. That's very
Be-
important that you guys
Because
cannot use LLM for this. You cannot just upload the paper and then give a different summary and bring it to us.
because it's a too
Yeah,
much, it's a
yeah,
totally plagiarism process, and your
yeah,
paper is not published on the site. you
yeah.
just you just get the LLM have regarding your synthesis of idea and other thing, but not copy and paste that. You give the copy of the PDF file to the LLM and give the instruction that give me the brief abstract of the paper, and they are giving you the brief again,
Yeah,
you copy and
yeah,
paste. And basically,
yeah,
the learning is that you go to the paper, three things you conclude that. First thing is the data sets, second thing is what the procedure you adopt, and last thing is what is the finding you got. These things are the related work, and after that you collectively built a chart like tabular form. In the last, one student like Hafifa,
Hyper. Yeah.
Haifa.
Yeah.
Haifa is also giving some target areas like 3 or 4 areas and 4 to 5 papers related work with that. And after that, he created a table which all the things are. Basically, these are helpful for us, and also your contribution is a learning phase of you. And for you people, I suggest that you people must concentrate on the graphical things like the statistical graphs, and these graphs are too much easy. You have a data and you just create such graphs from some commands, and in such a way you have an idea to utilize the Python for data analytical play. You are not a programmer, and your team is also not you building a programmer, but for your research perspectives, you must analyze the thing, and the data analytical process through Python is good for your learning point of view.
That's great. Azam, thank you very much. Uh, Before we go, there's another paper that Maria entered in the
Yeah,
group.
yeah, yeah. Wait a
I
minute.
think that one is much better. I just
Uh,
quickly went through it.
Wait a minute. I am downloading that. Yeah, the second paper is also available. You see that, huh? Basically, this is. I think that this is
Yeah, I think this is much
paper.
better. I think she should
Basically,
focus on this one.
yeah, yeah. Basically, I also utilize such paper for synthesizing
Ah, you used it. Yeah, I knew it. Okay, good.
quantification point of view. This paper is also available in that.
Okay, good, good. Maria, use this one. I think this one has a lot of
I
good
also
stuff.
I also use some diagrams or such thing in that paper, like architecture point of
Oh
view.
yeah,
Uh,
this one entrance phase. Yes,
Yeah,
yes, yes.
yeah.
Yes. Excellent.
You also use
I have
that.
a quick question. Sorry.
Yeah.
Sure, sure. Go ahead.
I was wondering, all these articles I'm very interested in like reading. Is it okay if I, instead of sending in the group chat, can I create like a shared Google document with different tabs for each person? Everyone can add in their notes for the research they've done. Because that way I doubt there'll be overlap of like people doing the same articles and stuff, but also just so we can look at the work other people are doing.
Basically, I also created a repo in the internet. Basically, I created that the repo. Wait a minute, I give you the link of the repo. Basically, this is a basic repo I am creating from the training perspective. The previous two training groups are also available, the all the notes and all the lectures on week wise, and also available that the um, if you
Yeah,
if
yeah.
you people
This is perfect. Mr. Azam, please share this with Nami as well, and
yeah.
reshare it in the group so that everyone gets it. Nami, instead of creating a new one, we can just put stuff over here, and I think it's a really good idea because I want everyone, the girls, to work in groups or as a team. So maybe in groups of twos and threes, even if they're working on the same paper or similar papers. I think it would be good to sort of communicate over there, even if it is by editing the same paper, for example. So I
The
think
idea is that if you people send me some paper according to your you search that, you send us on the good WhatsApp group, and I read that. If the paper is resemble that, I also make a other folder in that, like the search papers, and the every paper I upload that. After that, the basically this is the idea of the things which are uploading are not rough things. These are some projects. Similarly, that I research for different papers, and I also make a repo in my side to see that I am taking lot of papers. Research papers are available on that regarding to different things, and I make that and some target names and some regarding to the nature of the paper. For your summary, like see that I summarize that the paper or the hybrid segmentation, and after I am opening that paper, and you see that there is a nature of the hybrid nature, because The hybrid deep learning approach is using from the segmentation, and these are the idea when you collecting the information. You After collecting the information, and after that you summarize that in a good way. When you utilize that, basically, um, I have a lot of paper. I also upload that, approximately 50 to 60 papers I have downloaded from different good resources for the creation of our research paper. Basically, uh, I show you our paper, our first paper, because this is not in complete form, but hopefully in 1 week I complete that. It is our first paper. You see that basically the idea of the paper is that the early diagnostic of Alzheimer disease and explanation hybrid deep learning approach for using SMRI and fMRI and PET amyloid image analysis. Basically, this is the basic. This is the area which I am doing that. This is related work area. Basically, this is the area which you go give you the different examples. You see that the different examples we are getting from regarding to our paper, and after summarize that, this is basically the and after that you see that the some architecture more pictures, and after that where we get the modalities and pet images and different images. This is basically the theoretical things, like how type of things we are utilizing that structural fMRI, MRIs, and after the diagrams. And after that, where we collect the data sets, you see that we collect the data set for ADNI, and I also giving the ADNI detail, and similarly the OC, similarly the other other areas. And after that, basically, these are the formulas which we are calculating from the which are utilizing from different perspectives. And after that, you see that there are some tables which we are utilizing from results and other things. And after that, the explanation. Basically, this is the hierarchy of the people. The complete bibliography and other things are set at, and I hope that I restrict the paper within 10 to 15, 12 to 15 pages approximately, because
Also, let me add something, guys. This paper is Azam's top level secret because I think this is the first time I've seen it, and I've been trying to see it for I think 2 months now. But Mr. Azam is hiding it from me, so I've thanks to you guys, he's finally. Oh, there you go. He just hid it again.
basically I show you the I am the how you people do the research. Research is not easy. You take that, basically this is these type of folders we are building, approximately more data. You see that different models and different things are available, like your ADNI data set. There are a lot of ADNI data sets are available, and the NCA model we are creating different things. And this is basically the idea how you create the things and how the things are working in the professional way. Basically, these are the
Yeah, I
tricks.
think. Yeah, I think this is a good platform. Um,
Basically,
so, 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 yeah.
Sir Ahmed, one minute. You
Yeah.
see that this is over my first paper. Basically, I am publishing the IEEE. Two papers are also publishing in IEEE. And basically, this is our first paper. I show you. Wait a minute. This basically this is the first our paper which I am publishing on the platform of UL. Basically, the is a survey paper. It's published on 2019. The paper basically targeting the how we integrate the blockchains and IoT, the benefits and opportunity and challenge. And basically, this is our first paper, which I am published on IEEE. And approximately around about 100 plus citation is available on such paper. And the second paper is, if I am going to, this is our second paper. This is draft mode, and the full mode is available on IEEE. If you go to, I share my research link, which is, paper is also available. You also get such paper from Google Scholar. Google Scholar is also available such paper. And similarly, you people also contribute us, and the idea is that the first, we publish the sequel of three papers. The first paper is ready, and the I am working on the second paper. Some rough draft is calculated on my second paper, and after that, we also include you according to your contribution, because it's not a giving your name and make a
Yeah,
pile of
yeah. It's not just about giving the name. It's also
yeah,
about what your contribution
your
is and what your
contribution.
understanding is. It's very, very important. Azam, I think we're going to wrap up now. We're running quite late today. It's been an extended session, but that's good because next week we're going to be off since I'm traveling. So after 2 weeks, we will have the next session. And guys, for the research task, we'll update you in the group as well. Maria, use that second paper. I think it's good. All the rest of the girls, please send in your papers in the group chat so that everyone else can see them as well. Azam will compile the ones that he thinks are the best, and then he will upload them to the GitHub repository and share the link with you guys, so you guys can interact over there as well, and interact in the group as well, so you guys can work together on it. And thank you again, Nami and Dua. Dua, especially, we roped you in today into coming. I'm sorry the call extended so much, but I think it's been a good session today, and Nami gave us a very good oversight and review of what's going on in Canada. So that's very nice of her. Nami, we've added you to the groups, and we'll send you invites for future meetings as well. Also, we will keep you updated about the events going on with the company and the progress that we're making, especially with the clinical trials at the hospital and the research collaborations. Also, I would like you to keep sharing in the group as well as on LinkedIn any developments that happen over there in Montreal, any events that related events that you attend, and whatever's going on, any workshops. Send in pictures, send in updates. It's a good way to interact. And thank you very much for everyone joining in. Thank you, Mr. Azam, for the presentation. And I'll see you guys in a couple of weeks. Thank you very much.
Thank you very
Okay,
much.
Allah Hafiz.
You're welcome. Bye bye.
Thank you.